Alright, so this is going to be a Chapter 2 quiz review. I'll go over one problem exactly like each one of your questions on your quiz. So hopefully this will help you guys be ready for your quiz on Monday. We're going to start off with example number 1. Example number 1 says set up the definite integral. So this means we are not going to actually solve it. You'll be able to tell that when you're doing your homework assignment. We're just setting it up. That's all that they're asking for. So set up the definite integral required to find the area of the region between the graph of y equals 20 minus x squared and y equals negative 3x minus 50 over the interval from negative 5 to 3. Now, first thing that I always like to do is to get just a rough estimate of what this picture is going to look like. Main thing that I'm looking for here is which graph is above the other. So for y equals 20 minus x squared, I have a negative 50 over here, so I'm going to keep that in mind. So I'm not going to go too high for my negative, for my 20. But for this first equation, 20 minus x squared, I know that that is going to be a parabola that opens down and then is moved up 20 units. So let's just say that's about 20. There's our parabola. And then for our equation, negative 3x minus 50, I know that this is going to be a graph that goes through negative 50 and then has a negative 3 slope. So it's going to go quite a ways down there. And they're going to meet somewhere down here. So a really, really rough sketch of that. What we are actually going to find is the area between these two curves. So when I set up my integral, they give us the interval, so if they didn't give us this interval, we would set our two equations equal to each other and solve. But we do not have to do that because they gave us our limits of integration. So we go from negative 5 to 3. Then we're going to take the equation that is the highest, which this equation is up the highest, so we're going to start with 20 minus x squared, minus x squared. And then we're going to subtract the lower equation, which is our linear equation of negative 3x minus 50 dx. I'm going to simplify this down as much as I can to give myself a good answer. I don't want to take any chances on missing something. So we have 20 minus x squared. And then I'm going to distribute that negative sign, so it's going to make it a plus 3x and a plus 50. And I still have my dx out here. Now combining like terms, I'm going to have negative 5 to 3 of negative x squared plus 3x, and then plus 70, ooh, I forgot an x, plus 3x plus 70, and then dx. And I'm pretty sure on the MyOpenMath that it gives you that dx, but just make sure that if it doesn't give you the dx that you enter it in. And that's it. All you have to enter is this equation here, I believe, and then it gives you little boxes for your limits of integration, and you're done with number 1. Alright, and here's example number 2. So example number 2 is the one that kind of seems lengthy, but it's just breaking it all up for you. So the shaded region between the graphs of y equals negative 2x squared plus 20 and y equals 3x minus 15 is displayed below in orange. So we have a quadratic equation that opens down again, along with a linear equation that cuts across it. And then we want to find the area of everything in the orange. So first thing that we want to do is find our limits of integration, which we find by setting our two equations equal to one another. Also, that is what they're asking for. We'll call this part A. Okay, sorry about that. I had to help my daughter determine what size shoe she needed to buy. Alright, we are all good now. So we are setting these two equations equal to each other. So we have negative 2x squared plus 20 equals 3x minus 15. And I want to get this all equal to 0. I want a positive x squared, so I'm going to move everything to the right. So we'll end up with 0 on the left, and then on the right we'll have 2x squared plus 3x, subtract 20 from both sides, so we'll have a negative 35 over here. And now we need to factor that, so let's go ahead and factor that. I always like using the AC method, so A times C is negative 70. And then our middle term that we're looking for is 3. So what are the factors of negative 70 that add to 3? And I'm thinking that 10 and negative 7 would work great. So 10 plus negative 7 is equal to 3, and 10, I ran out of space there. And 10 times negative 7 is negative 70. So that's what we're going to split up our two middle terms to, or sorry, our middle term to. So plus 10x and minus 7x minus 35. And then we want to factor that by grouping. So we can factor out of the first two, we can factor out a 2x. And then what's left, having a hard time putting in my parentheses there. Just make sure we remember there's a negative there with our 7. All right, so factor out a negative 2x, and then we have an x plus 5 left. And then factor out a minus 7, and then we would have an x plus 5 in the parentheses. So that's going to work out good. So we have 2x minus 7 and x plus 5. That is equal to 0, so therefore x is going to equal 7/2. Let's write that as 3.5. Or x must equal negative 5. So that puts our limit of integration. That means this point, which looks exactly right, as negative 5. And then this point over here is 3.5, which looks just perfect. So I've got negative 5 to 3.5, and then that is our answer for part A. A typical rectangle is shown in the diagram located at the position x. What is the height of this rectangle in terms of x? So they're just asking us, what is the distance at any given time between these two equations? And we're going to put that in terms of x, because then that is going to allow us to change that height wherever we're at in that equation. So we find the height by taking the top equation minus the bottom equation. So that equation that is the highest is our upside down parabola, which is y equals negative 2x squared plus 20. And then down here we have our linear equation, which is y equals 3x minus 15. So we're going to find our height by taking the higher equation, negative 2x squared plus 20, and subtracting the lower equation. I'm going to put parentheses around here so we make sure to keep track of which equations are which. The 3x minus 15 is the lower equation. So now go ahead and distribute through that negative. All right, now we can combine like terms. So our height becomes negative 2x squared minus 3x plus 35. And then that is the equation that we need to integrate. I'm going to move my screen up. All right, so now we are down to where we need to find the total area of the orange region. So we need to find the integral between the 2 points that we found, which was from negative 5 to 3.5, and then we're going to integrate the equation, or the height, of each x box that we found. So that equation was negative 2x squared minus 3x plus 35, and then we have a dx here. And then when we integrate all of this, we get negative 2/3 x cubed minus 3/2 x squared plus 35x, and that is going to be evaluated from -5 to 3.5. All right. So now we're going to go ahead and evaluate that. So we're going to plug in 3.5 first. And then I did plug these into my calculator and use my table to evaluate all of this. So plus 3.5, no, sorry, that's 35x. Well, it's going to be the same thing eventually. 3.5 times 35 on that one. And then subtract, I'm just going to write them down here, subtract what we get when we plug in the 0.5, or -5 is what that is supposed to say. That's a -5, not a 0.5. Okay. So then we have -2/3 times -5 cubed minus 3/2 times -5 squared plus 3.5, no, sorry. See, I messed myself up doing that, times 35 times -5. My pen is acting up a little bit, so sorry that this is all kind of running together a little bit. Okay, so plugging all of that in to my calculator, I ended up with 75.542 minus -129.166, and then ended up with a final answer of 204.708. And that's all for example number 2. All right, number 3. I only have 2.5 minutes left before this end video clip is going to end on me, but this is a pretty simple one, so I'm hoping I can get through it. If not, I'll skip back and you'll never know. All right, so our 2 equations. We have a quadratic equation, pretty steep quadratic equation because it's 6x squared. And then we have the equation y equals 6x. And then we are going to, they meet right here at 1 and 6. And then we are trying to find the area between all of that. All right. Notice we're not rotating anything so far. So not using 2 pi for anything. We are going to be using in terms of x. So we're going to be going between 0 and 1. And we are going to be taking our cross section, or our little pieces right here. So those are dx pieces. They are the difference in x for our width. And then we are going to take our top equation, which is actually the linear equation. So we're going to have 6x minus 6x squared dx. And then integrate that. We will have, well, let's see here, do 6/2 x squared minus 6/3 x cubed, evaluated from 0 to 1, which that becomes 3x squared minus 2x cubed, evaluated from 0 to 1. Plug in the 1, we end up with 3 minus 2. Got 30 seconds, which equals 1, and that's my final answer. And that's all we've got to do for that one. I even got 20 seconds to spare.